Okay, what we have here is a problem that's a conic section, and it's in general form right now. So what we first need to do is identify what type of conic we're dealing with, and then we're going to go ahead and put this back in standard form, and ultimately we will end up finding some of the points on the conic section and graphing it. So first way to recognize what type of conic it is, really the best way to recognize what type of conic it is simply by looking at your x squared term and your y squared term. If you have both an x squared and a y squared term, it's either going to be a circle, ellipse, or hyperbola. If you just have one x squared or just one y squared, okay, then it'll be a parabola. Now, here we know it's going to be a hyperbola because x squared is negative. So we have one negative, one positive. So this is going to be a hyperbola. Now, since the y squared term is positive, okay, we're going to go ahead and pull that out first, all right, to help us write our equation. And we're going to put that together with the other y term in the problem. Okay, this 24y. And then, of course, we'll put the x terms together, and we'll move the 44 to the other side of the equation. So there's our first step, is put the 4y squared and the 24y together, and then factor out a 4. Because ultimately what we have to do with these problems is complete the square, so we can rewrite it back in standard form. So in order to complete the square, we can't have a coefficient with the y value, so we factor out a 4, factor out a positive 4 for negative 24, and you get negative 6. Leave ourselves a little space so we can go ahead and complete the square. Do the same thing with the x's, but since x is negative, we want to factor out a negative 16. When we factor a negative 16 out of this, negative 32. When we factor a negative 16 out of this, it becomes positive 2x. Next step is to complete the square. If you guys all recall, completing the square means to take half of those middle terms and square it. So half of this middle term, half of negative 6 is negative 3, and negative 3 squared is positive 9. Over here we'll have half of positive 1, positive 1 squared is positive 1. Now notice what we did. We added on a 9, we added on a 1. Okay, so since we added these numbers on the left-hand side of the equation, in order to keep the equation balanced, we also need to add them onto the right-hand side. Something you need to notice, though, is that it's not just 9. It's actually 4 times 9. That is the problem. So that's the number we actually need to add to the other side, and you can see that right there. That we're adding a positive 36. From the x's, we had a negative 16 and a positive 1. So we had to add on a negative 16 to the other side to keep the equation balanced. So we just go ahead, factor. It's always going to be y, whatever half your middle term was, x, whatever half your middle term was. Now, if you guys recall, we never have this number here except a 1, okay? The equation is always set equal to 1. So in order to set this equal to 1, what we have to do is go ahead and divide out a 64. So we divide a 64 to all three of these terms here. And when we divide by 64, you can see what's going to happen. We just reduce the fraction. We're going to reduce the fraction, and 64 divided by 64 is going to give us positive 1. And there we are. Okay, 4 goes into 64 16 times, right down there. And 16 goes into 64 4 times right here. And that's our standard form of the equation of the hyperbola. From this, we're going to be able to find a couple values that'll help us graph it. Okay, one thing we want to recognize right away is that the y is positive, and what this does, this tells us which way the hyperbola is correlated. In this case, it's going to be opening up and down because the y term is positive. Whatever's positive, that's which way it opens. Y values are vertical, so our hyperbola is opening up and down. If it was x, it would open side to side. So we can easily identify the center as negative 1, positive 3. Next thing we're going to do real quick is identify what a and b are. A is always the square root of whatever that positive term is. So a is going to be 4, and then b will be the square root of x. So b will be 2 in this case. Now these tell us how far to move left, right, up, and down from our center to help us sketch our graph. We need to find C so we can go ahead and find the foci. So we find C using this formula with the hyperbola. So we plug in b squared and a squared and go ahead and solve for C. And C comes out to be square or 2 square root of 5. And that's going to help us find the foci here in a second. So to find your vertices of your hyperbola, remember there's only 2 vertices for a hyperbola. You always add on whatever the square root of this number is of your positive term. So since it's under the y values, we're opening up and down. So we're going to add and subtract this 4 because we need to move up for one of the vertices and down from the other vertice from the center. We're going to add and subtract 4 to the y value of the center. So when we add 4, you're going to get 7. When we subtract 4, you're going to get negative 1. There's 2 vertices. Now we do the exact same thing to find the foci. We're going to add and subtract C, whatever C was, to the y value. Oops. Right here to the y value. Okay? Because the foci, the center, and the vertices all lie along the transversal axis here. So we add and subtract 2 squared 5. And there we have the foci. Alright, let's go ahead and graph this. We have all our information over here at the left. To graph, guys, very, very, very simple. Okay, just plot some of our points. We're going to go ahead and we're going to plot our center. Center's at negative 1, positive 3. There we are. Plot our vertices. Negative 1, positive 7, and negative 1, negative 1. Now, it's pretty easy to see that the distance from the center to the vertice is that 4 units long that we got from A over here. Okay? And then, of course, guys, we have to go ahead and plot the other 2 values. Okay? We went up and down 4 because it's under the y's. We're going to go left and right 2 because x is horizontal change. So we go left and right positive 2 units. That's our b value. And what we're going to do with these points, okay, it's very similar to that of an ellipse. An ellipse, normally we would sketch the ellipse through these vertices right here and be done with it. For hyperbola, however, what we're going to do is actually sketch a rectangle around these points. And what that's going to do is that's going to allow us to go ahead and find the asymptotes. Okay, the asymptotes that it's approaching. Except my rectangle's kind of bad there. Get a little bit smaller, make it pass through. Alright, here we are. So there's a rectangle that's going to help us sketch it. Remember, our hyperbola is opening up and down because y is positive. So, last thing, guys, all we have to do is really sketch the asymptotes. The asymptotes are going to pass right through the diagonals. So we sketch some asymptotes in here. Straighten them out for you. And there's our asymptotes. Alright, sketch a graph. All you have to do, start at the vertice, right there. And we're going to curve out gently, heading towards that asymptote. The further away we get from the center, the closer this graph gets to the asymptote. But remember, never crosses the asymptote. And there we are. Now, something else we do want to end up finding is the equations of the asymptotes. So to come up with the equations of the asymptotes, there's 2 ways to do it. One is to simply look at what these lines are right here and try to figure out what the equation is based on the line. But remember, we can always mess up with our graph a little bit, and that's going to throw us off. So what we're going to do is we're going to find this real quickly using, sorry, we're going to find this real quickly using the formula. Okay, and the formula to find your asymptotes is right here. All right, we use y minus k equals plus or minus a over b times x minus h. It's just point slope formula where a over b is your slope. Now in this case we use a over b because the y value is positive. All right, if you guys all remember slopes rise over run. So more or less, whenever we go to do these asymptotes to find the equations, we always do whatever that square root of that number is under the y over the square of the number that's underneath x. The rise, because y is up and down, over the run every single time. Doesn't matter if x is first or y is first. You do the number under the y over the number under the x. And here we are. We just plug in our values. Y minus 3, that's the y minus k. X plus 1, that's the x minus h. And a was 4, b was 2. And we have to do the positive of that, and we do the negative. Now what we're going to do is some real quick algebra. Simplify it out. And there's the equation of our two asymptotes. 2x plus 5, negative 2x plus 1. So you can kind of see how my asymptote is a little bit off. Kind of passes through 5. There it is. And then this one was supposed to pass through positive 1. Alright, looks a little bit better there. Okay, slope of negative 2 for this line. Slope of positive 2 for this line. And that's it, guys. That's how you graph a hyperbola.